Okay. Hi, everybody. I'm Anastasopoulos. I'm a postdoc here at LTI, and thank you, Alan, for having me teach on machine translation. So let's just start. So have you guys seen anything on machine translation before? Like, have you talked about it in class, or just mentioned it in passing, or yeah?
In another class, yeah.
Okay, in another class, like NLP or another what class?
Deep learning.
Oh.
You're implementing LSTMs.
Oh, okay, okay. I don't know. Who has used Google Translate? Okay, slightly more people. Okay, good. So the main idea, going back all the way to right after the Second World War, when people were very interested in cryptography and the Enigma machine and all of those, and they thought, wait a minute, the same idea can be applied to language. Right, so Warren Weaver thought or said, allegedly, I assume, I don't know if this is the exact quote, that basically, when I look at a document in Russian, right, it was the height of the Cold War, you wanted to know what the Russians were saying. When I look at a document in Russian, that really is not a document in Russian. It is a document that was written in English that has been encoded into these weird symbols, okay, that kind of look like Latin letters, but they're not. Okay, so so that's the main concept, right? That was behind the whole idea. So I just want to. Is anyone from New Zealand? I assume no. Okay, or anyone speaks Maori? All right. So I just wanted to show you that you can apply the same principles that are under the hood of every machine translation system. If you wanted to do the same thing. So you have this example here, which is English and Maori. It's from New Zealand. And you have, how you can order, I'll have a flat white. You can just say, he mo wai maku. Or I'll have a short black is he pango poto maku. Okay? So looking at that, who wants to take a shot at telling me how it would be to order an espresso? If you assume that the word for espresso is espresso. In Maui. Yeah.
Espresso maku.
Okay. I am pretty sure that's correct. But why? Yeah.
If you look at cappuccino, it's basically the same thing. It's cappuccino maku. So they still use maku as a word for coffee at the end. And then his I, and then like I'll have, or probably something like that.
All right.
A descriptor in between he and maku describing.
Okay, awesome. And how would you order someone else? How would you order a long espresso? Yes. Oh, you can read it. Yes. Okay. And how do you figure that out? You looked at the short and long examples, right, where everything is the same, and the only thing that's different is the short and long, and you found the only difference in the Maori side, right? So, okay. So who can tell me what is the translation of he? Yeah. Yeah. What do you think is the translation of he in English? Yeah. I will. And what is the translation of maku? Ha. Okay. So these are two different words, right? Yes.
One would be I'll have and then coffee. Like the word for coffee.
The maku?
Yeah.
Could be, right? It could be he is I'll have the type of coffee, and maku is the actual coffee, so these are the modifiers. Could be. We'll come to that later. But the point is that you didn't really need to know that. Okay? You didn't need to know what he means or what maku means or anything else in order to create the I'll have a long espresso sentence. Okay? And the good thing is that data like that can give us these type of clues. So what in NLP we call parallel data, exists in many different forms. So you might have this example. You might have, the United Nations that has their websites, or they translate everything from their proceedings into 6 languages, like English, Chinese, Russian, Arabic, French, and Spanish, I think. Or you might have the Bible that has been translated in 6 or possibly every language that exists in the world. Or you might have the Harry Potter books that have been translated to more than 200 languages. Or then you might have examples like the ones that you see in Craig Street, or you might have examples that are really, really old, like the Rosetta Stone. So, do people know what this is? Like, okay, I said it's a Rosetta Stone, but what it was used for? Yeah.
It was the same text written in 3 different scripts I like to translate.
Right. So one of them was ancient Greek, which in the modern era we knew how to decipher it. We knew what it said. We could translate ancient Greek into, say, Latin or modern Greek or modern English. And the other 2 were 2 scripts that had not been deciphered yet. And they were the hieroglyphics and the demotic script of ancient Egypt. And by realizing that these things were essentially parallel texts, oh man, I forgot their names, but 2 French guys, were able to decipher the 2 Egyptian scripts. Do you remember the names? Yeah, okay. All right, so, yeah.
I'm always curious, is there a way for us to verify that those are that's correct with the same script and that we actually translated these properly? Or is this all?
Yes, there is a way. There is a way to verify. So let me put it this way. If I told you that, so let's say we find an assignment between words for this text that works and we think it makes sense. Okay. If it doesn't work in any other Egyptian text, so essentially, if you can train a system that goes from Greek to Egyptian, you can train a system that goes from Egyptian to Greek. Okay. So if you create a system based on this, okay, presumably whatever you create would work. Okay, it would possibly make sense given these texts. Now, if you go into another text and it doesn't work on either direction, so it doesn't produce meaningful text in either direction, then you can be like, okay, maybe your system is fine.
I guess I was looking for is it's not so that they're saying, hey, we have this strict, it goes from the proper Egyptian to the proper Greek, but it's going from Egyptian to something gibberish, so it must be wrong. Is that what you're saying?
Right. Yes. Yeah. But using these, they were able to essentially map every ideogram to letters, I think, or bigrams, if I remember correctly, by characters. So, and then they were able to see that, in all these other different scripts, it actually made sense and it produced meaningful sentences. So, interestingly, the thing that was used as a clue to realize that these are parallel texts were proper names. And the reason for that is that proper names are very often just transliterated between languages. And you could see that in the Maori example, right? Cappuccino was written as cappuccino, which, or latte was rate because the sound L is not in the Maori language, right? So that's how they started deciphering some of the letters. And then from that, because that was work done by hand. It wasn't done by any NLP system or computational NLP, right? But my point is that you can simulate the exact same procedure computationally, okay? And the way that we do that is by essentially what the idea behind it is just noisy channel NLP. So the idea is that you have a clean sentence, okay, that was in English, and that went through, someone went in and scrambled it and added noise to it, and now it was French. Okay, so what you have to do is go the opposite way and decipher it back to what it was originally meant to be. So you have a confusing foreign sentence, and given that, you want to find the best possible English translation. All right? And if you put that in math speak, that is exactly what you want. So you want this E, okay, which is the best possible, so that's the argmax, the best possible translation for that F that you observe, okay, the sentence F in French that you observe. And now, given the conditional probability,